So for this problem, we have to find this limit. If we just try and find it directly straight away by plugging in x equals 0, we get the numerator is 0. The denominator is root 2 minus 1 plus 1, so that's minus root 2, so we have 0 over 0. So this tends to 0 over 0, which lucky for us means we can use L'Hopital's rule. And that basically states that this limit here is equal to the limit of the derivative of the numerator over the derivative of the denominator. So we can see if by finding those derivatives we can calculate that limit, and we know by L'Hopital's rule that that's equal to the limit we want. So let's call the top function f of x, and then we're going to find the derivative of f of x. We're using the chain rule, so we bring down the power, we get 2 sine x, but then we have to multiply by the derivative of sine x, so that's cosine x. And then this bottom derivative, we have g of x is equal to root 2 minus the square root of 1 plus cos x. Finding the derivative of this, the root 2 just vanishes because it's just a constant term. And then here, okay, so we take this as the power of positive 1/2. So we bring that down, that 1/2, and then we have to multiply by the derivative of the inside here, which is just negative sine x. So that's why I haven't done a negative sign here. So now we have a sine x, and then we have 1 plus cos x to the negative 1/2. So we want to find the limit as x tends to 0 of f dash of x over g dash of x. That's equal to the limit as x tends to 0 of 4 sine x cos x 1 plus cos x to the power of 1/2. We could write that as a square root over sine x. As we're taking the limit, x is non-zero, so we can do cancelling. There's no problem, issues with zeros here with the sign. And then we take the limit. So this just goes to 1. Okay, this goes to 2 to the power of 1/2, or root 2. So this is 4 root 2, and that is indeed our answer. Thank you for watching this problem. If you did enjoy this video, please be sure to subscribe to the channel. Any support is much appreciated. And let me know what type of content you want to see moving forward. Thank you very much for watching, and have a good day.